Have you ever wondered what makes a great lesson, well, great? It's not some kind of magic, it's actually architecture. Today we're going to pull back the curtain on the blueprint of a modern 7th grade math lesson to see how really intentional design can completely transform learning. Yeah, think back to middle school algebra for a sec. For a lot of us, right, it was kind of a blur of abstract letters and numbers on a blackboard. Just a world of X's and Y's that felt like it was a million miles away from our actual lives. But what if it didn't have to be like that?
Just look at this comparison. On the left, you've got your classic abstract inequality. But on the right, it's the exact same mathematical problem. But now it's a story. It's a real-world challenge you have to solve. And that simple shift, from just symbols to a story, that's the secret sauce of modern teaching.
You know, a great lesson doesn't just happen by accident. It's engineered. Just like building a skyscraper, it all starts with a really detailed blueprint. You have to plan out exactly what students will know, and more importantly, what they'll be able to do by the very end. So, these are the actual learning targets for this lesson. And notice how specific they are. We're not just doing inequalities. No, students are expected to build them, to graph them, and to fluidly move between tables, graphs, and equations. This isn't just about finding a destination. It's a detailed roadmap for a much deeper understanding. And here's the why behind it all. This quote comes straight from the curriculum guide itself. It really emphasizes how important it is to connect those abstract symbols to something you can actually see. This isn't just a friendly suggestion, it's the core principle that drives this entire lesson design.
Okay. So we've got our blueprint. Now, how do we actually get there? Well, you don't start with a dry formula. You start with a story, a scenario that gives all the numbers context and makes them meaningful.
So, the story we're going to use to anchor this whole lesson is about a deep-sea submarine on a dive. It's a simple premise, but it's engaging. And the key data points are super clear. It starts at 0, and it has a constant rate of descent.
And right away, that story gets turned into hard data. This table makes the relationship between time and depth totally concrete and visible. You can see it right there. At 0 minutes, we're at 0 depth. At 1 minute, minus 480 feet. You can already see the pattern starting to emerge, can't you?
So this is a crucial step. We have the story, and we have the data. The next move in our blueprint is to transform those numbers into a picture, a process that educators call using multiple representations. And here's where the magic happens. We plot the points from our table onto a graph, and bam! We get a straight line. Suddenly, that abstract relationship between time and depth is something we can actually see and analyze. This is that powerful connection the curriculum guide was talking about.
And you know this visual pattern we're seeing? It actually has a name. It's the unit rate of change. In our story, it's those 480 feet the submarine descends every single minute. By giving this concept a formal name right after students see it on a graph, the lesson connects their visual intuition to the official math vocabulary. It's brilliant.
Now, the graph isn't just a picture. It becomes a powerful problem-solving tool. The lesson actually asks students to estimate, at what times is the sub less than 1,400 feet deep? You can literally see the answer visually before you even think about writing an inequality. You're using the picture to build an understanding of the algebra. And that's the key takeaway. Turning abstract data into a visual makes these complex ideas feel way more intuitive.
So, the content is perfectly structured, but that's only half the story. A great lesson plan also includes a playbook for the teacher, a guide for anticipating problems and, sparking some real thinking. And check this out, this is a peek behind the curtain into the teacher's guide. These aren't just any old questions. They are probing questions, specifically designed to make students explain their thinking. How can you tell? How do you know? This is where the real, deep learning actually happens.
You know what else a great lesson plan does? It anticipates where students are going to get stuck. The guide explicitly warns the teacher about this really common mistake. It's all about being prepared to turn a moment of confusion into a powerful learning opportunity. And what about students who learn differently? Well, the plan is flexible. For visual learners, using colored pencils helps them literally see the connections. For kids who need a bigger challenge, there's an extension problem that really pushes their thinking. And for those who need a little extra support, graphing technology is there as a scaffold. It's all about meeting every single student right where they are. Okay, so we've got this beautifully designed learning experience. But does it actually work? The final piece of the puzzle is to see how these skills are measured on a real state test. All right, let's look at a released test question. It's a word problem about office space.
And what's the core skill being tested? Translating a real-world scenario into an algebraic equation. Sound familiar? It's exactly what the submarine lesson was designed to teach. We can also see that just over half the students statewide got this right.
Here's another one, this time with an inequality. A student rides fewer than 30 miles. Just like our submarine problem, it's a story with a constraint. Students need to build the right inequality, a skill they've been practicing.
And this one is my favorite. The test isn't just made of word problems. It actually uses visual models, directly assessing if students can connect a picture to an equation. This is proof positive that the lesson's focus on tables and graphs isn't just some nice teaching strategy, it is absolutely essential preparation for what students will be asked to do.
From the very first learning goal all the way to that final test question, every single element we just saw was connected. The story, the table, the graph, the teacher's questions, all of it was deliberately designed to build a specific, durable, and connected understanding of math. It really leaves you wondering, what would be possible if every learning experience was constructed with this level of care and intention?